So looking at homework 6, there are 9 questions, but you only have to do 3 of them. Any 3 that you'd like. So I'd like to just quickly run through and make comments about some of these, but not all of these. I will not work out the entire exercise. You can do that, but I will help you to set it up. You have the solutions with you in Canvas. So just looking at number 1, it essentially wants the rocket's maximum height. The keyword is maximum. So for that one there, I'd go negative b over 2a, where a is -5, b is 30, and c is 10. If I knock out negative b over 2a, that's going to tell me when the rocket is at its maximum, right? Because here, that's the vertex, that's the maximum. This is time, and this is the height. It's really not x and y, it's t and h. T is the time when it happens, and h is the actual maximum height during that specific time. So negative b over 2a is going to give you a time frame. Whatever time you get, you plug that back in here to get the actual height, because that is the actual goal. For problem 2, we have a model that looks like this. Let's call these heights x. Let's call that entire length y. And as it pertains to the amount of material that I have 900 meters of fencing, and that is going to be cut into 3 pieces of x and 2 pieces of length y. So that's one equation. The other equation is the area. The area of this rectangle is length times width, or base times height. So let's call it x times y. And then like we did in class, let's get this y alone. So let's isolate this y. And if you do so, if you get this y alone, you'll see that it's going to equal 450 minus 3 over 2x. And now what we can do is we can take this and we can plug it in for y, because I want my area function to have 1 variable, not 2. So now I have 1 variable, which is just going to be x. 450 minus 1.5x. So this really mimics the one we did in class. Let's distribute. And after I distribute, I will simultaneously organize pieces to my liking. So if you go negative b over 2a, that's going to tell you the x coordinate, or that's going to tell you rather this height x, right? It's going to tell you this height x, whatever this is. And then whatever that is, that's going to be some number, who knows? Whatever x is, plug it in here to get the y. So then you'll have x and y. And then once you know x and y, the dimensions, you can plug them in there to get the actual area. And that'll be number 2. Now for number 3, let's see. So we have people going to a dance, 300 people, and they're going to raise it 10 cents. But every time you do so, you're going to drop 5 people. So here is the fee. The fee is $4 plus 10 cents times the number of times you bump up the cost. I'll just put PPL for people. There are 300 people, but I am going to lose 5 people for every time that I bump up the cost by a dime. So this is what I have. Now, as it pertains to revenue is going to equal the number of people times how much each person pays. So it's 300 minus 5x and then 4 plus 0.10x. I'll leave it there. Do what we did in class where you distribute. And once you go distributive property, you're going to have something that says ax squared plus bx plus c, like we've been doing before, right? Make this to look like this, like we've been doing. And then what you want to do is you want to go negative b over 2a, because that's going to tell you the value of x. And then what did they want? They wanted to know what ticket price will produce the greatest revenue. So once you know x, whatever number that is, plug it in here and do that, because that represents the fee or the ticket cost that you should set to make the most money. And then what's the other question? Determine the dance committee's greatest revenue possible. Whatever x is, some number, you plug it in there. So you plug x into here if you want to know the ticket cost. You can plug x into there to see how many people you'll have. I don't think the question asked for that, but there it is. But then you take x and you plug it in here, or even there if you want, to see the maximum revenue possible. Let's see, question number 4 looks a lot like question number 1. I know it has a tricky part in part B. I'm not too worried about number 4. And then for 5, we can knock that one out real quickly. So for 5, this is what I would do. So you have Nancy walking across a rectangular field. So for number 5, we have a rectangular field. Let's say she's right here. She goes for a walk this way, 15 meters. Then she walks around the edge, either like that or like this, it doesn't really matter. And then it says the total distance is 36. Let's call this X and Y. So it turns out 15 plus X plus Y, that's how much her walk was. That's her entire walk this morning, which is said to be 36 meters. And that's actually the only number we have. These numbers, that's all we have. What do they want? It says, what are the dimensions of the field? So this is your field. The dimensions are X and Y. We have to solve for X and Y. It seems like an impossibility because you have 2 variables but only 1 equation. But please recall that a rectangle has 4 right angles. And since that's the case, we have here a right triangle. And because we have a right triangle, we have permission to access the theorem of Pythagoras, Pythagorean theorem. So then we can go 15 squared equals x squared plus y squared. Remember that? A squared plus b squared equals c squared, where c is the hypotenuse and the legs interchangeable because it's addition. So this here becomes a system. Don't really need the m for now. So this becomes a system. Why don't I subtract 15 from both sides? So it's x plus y equals 21. And then x squared plus y squared equals 225. Because that's here and that's there and that is that. I subtracted that from that. Okay. So this is what I have here. Now, how do I solve this system? There's a couple of different ways, but maybe what I can do is I can get this y alone. If I get this y alone, it'll say y equals 21 minus x, right? If I move this to this side, and then what I can do by substitution is I can take this, which is y, and I can plug it in here. So I'd have x squared plus stuff squared equals 225, where y is that. And then this is x squared plus 21 minus x. 21 minus x equals 225. And let me just say this. You can go like that. You can combine like terms. You can get it into ax squared plus bx plus c equals 0. You'd have to subtract the 225 at some point. And then you can solve that equation by using the quadratic formula. And that'll tell you what x is. And then whatever x is, you can plug it in here to find the value of y. So there's more to that, but try that if you'd like for number 5. Number 6, I'm not too worried about that for now. 6 and 7 are kind of the same. We might revisit that concept sometime in the future. Number 8 looks a lot like the other one, and I'm not worried about number 9. So for number 8, real fast, for number 8, we have 1, 2, 3, 4, 5, 6 x's, and then we know that we're gonna have 2 y's, and that's gonna give us the 800 feet of material. And then the area is gonna be x times y. So this one really mimics the one that we did earlier. If you get this y alone, it's gonna be 400 minus 3x. So this is gonna be x times y, which is 400 minus 3x, and just go from there. So these are just some suggestions that hopefully were helpful. And for 6 and 7, again, we'll do some of those maybe in the future. But for now, hopefully that was helpful. So just pick any 3 problems, give them a go, and you have the answers in the other page. So there you are. I hope that helped. See you guys in class.